So we're thinking back to 151 for reaction rate. And you know, their temperature, pressure, all these things that increase probability of collisions happening also increase reaction rate. But you can get to a certain point and then those things negatively affect things too. So let's talk first about temperature. So temperature does a couple of different things. One, there's kinetic energy. Kinetic energy is where all those molecules are moving around back and forth, right? So if you increase the temperature, you increase the kinetic energy involved in the system, which means the molecules are moving around faster. If the molecules move around faster, they're more likely to randomly run into each other because they're just moving more. If you're moving this slow and you have 10 seconds, you're only going to move into, right, there aren't enough things. But if I'm moving like this, in 10 seconds I can run into this, that, and that. So your odds are higher that you're going to run into something that you click with, right? The faster you move, the more likely you are to hit the enzyme or another molecule. You just hit more in the same time. So temperature, unfortunately, can also affect the condition of the enzyme. So we, at a temperature greater than 98°.6, really 100.4 Fahrenheit, are considered to have fever. Fever denatures proteins. Most of our proteins are set to exist at 98.6 degrees. There are a few adaptations in our immune system whereby a few of these things work better at 99, 100, 101 degrees, but for the vast majority of our system, fever starts to denature our proteins. Enzymes are proteins, so they're affected by this as well. And I know everybody's taking these in different order, but in 410 they talk a lot about what happens to cooking, or even if you go back to 210, what happens to your proteins when you cook them. We can denature too. And we live in a really, we being the enzymes, live in a really narrow range that works well for us. Okay, also pH. So chemical changes can happen in the enzyme, right? If you're too acidic or too basic, you have chemical reactions that are going on with other things that can attack your proteins. You also have changes within the proteins themselves. Proteins are really complex molecules with a lot of amino acids, and those amino acids have side chains. So at physiologic pH, those side chains may be attached. If you change the pH to 6, those side chains may choose to dissociate. And what was attached to a molecule at a pH of 7.4 is now dissociated and running around behaving like an acid at 6. So you can change, and if you've dissociated that side chain, you've also changed the way you've bonded to something else, and then the enzyme starts to change its configuration, and then they start to fall apart. Okay, so enzyme substrate concentration. So obviously, up to a given point, the more of something you have, the more likely you are to run into it, right? The more these things, if you've got 20, you're much more likely to pick one than if you've got 2. However, in a cell, there are thousands and thousands and thousands of proteins, and thousands and thousands and thousands of substrates, and all of these things are happening at a given time. There is only room for so much of any of them. So you reach what's known as the saturation point, whereby either the enzyme or the substrate is completely paired. You could have excess substrate and you just only have so many enzymes, or you could have excess enzyme, but you have used up every substrate that you have and you're holding them to happen in the reaction. Because the cell has so much work to do in so many different areas, it cannot take infinite amounts of enzyme or substrate, so when you've reached the max there, that's the saturation point. You can change the amount of enzyme you have. And when we do transcription translation review, we're going to talk about upregulating proteins and how that happens and the signals that are required to do that. But it takes work to do that, right? Producing proteins is something that requires energy for the cell. So it has to be signaled by something, and there's a trade-off. In order to make that protein, they have to have enough amino acids to make that protein, and they have to be receiving a signal in the nucleus that says that's more important than other things. So you can go around a saturation point to a limited extent, but not really at the moment, because it takes time to get a signal into the nucleus and produce a protein. and take resources from something else. It's just all a balance, and there's an internal regulation within the cell, and there's a complex system we'll talk about how that works, but that's why you hit a saturation point. Okay, so